Good day, everyone. Have you ever wondered what happens to the water after fabrics are dyed, or where all those bright colors go after the process? My name is Christabel Aminyampo, and today I will be taking you through the introduction, background, and discovery of our topic: environmental impact of synthetic textile dyes in Ghana. We all love brightly colored clothes, but have we ever stopped to think about how those colors are produced and what happens after they are washed away? Synthetic textile dyes are widely used because they produce bright, attractive colors, are durable, and are cost-effective. In Ghana, they are commonly used in cities like Kumasi and Accra, where textiles production is very active. However, despite their importance, the improper disposal of these dyes has become a serious environmental concern. When dye containing wastewater is released into rivers and other water bodies without proper treatment, it can harm aquatic life and pose risk to human health. A major group of these dyes is known as the azo dyes, which contain the azo-functional group. These dyes were first discovered by Gries in 1858 and remain widely used today. So while these dyes make our clothes beautiful, they also raise an important question: at what cost to our environment? In this work, we explore the chemistry of azo dyes, their application, their environmental impact, and possible ways to control their pollution. I will now hand over to my colleague to take us through the next.
Here we are going to talk about the synthesis and chemistry of azo dyes. Azo dyes are a large class of synthetic dyes characterized by the presence of the azo-functional group. Azo group is a double bond between two nitrogen atoms. This group usually links two aromatic rings. The key functional group in azo dyes are the azo group, aromatic rings, and amino groups. The bright color of azo dyes comes from the conjugation and electron delocalization. Examples of these azo dyes are the azobenzene and the methyl red. Synthesis of azo dyes involves two main steps, and the first one is the deazotization, where an aromatic amine reacts with the sodium nitrite or hydrochloric acid, and this reaction is carried out at a low temperature to form a diazonium salt. And the second one is the coupling reaction, where the diazonium salt reacts with the phenol or another aromatic amine, where the result yields an azo dye.
Ghana, especially near the busy textile hubs, a lot of untreated dye wastewater gets discharged straight into our local streams and river systems. When this dark chemical heavy water enters our bodies, it acts like a giant blanket blocking out sunlight. This stops aquatic plants from photosynthesizing, which drops oxygen levels and suffocates fish and other aquatic life. But it doesn't stop there. These toxic chemicals can accumulate into our food chain and seep into groundwater. For local communities relying on these sources, it poses serious human health risks, ranging from severe skin irritations to potential long-term chronic illness. It's a massive challenge, but it's not hopeless.
The control measures to reduce pollution. First, industries should treat wastewater before releasing it into rivers. This helps remove harmful dyes from the water. Second, the government should enforce strict environmental laws so companies do not pollute the environment. Third, industry should use eco-friendly dyes that are less harmful to humans and nature. Lastly, there should be public education and awareness so people would understand the danger of dye pollution and act responsibly. Conclusion: azo dyes are very useful because they give bright and long-lasting colors. However, they can cause serious environmental and health problems if not properly managed. Therefore, it is important to balance their benefits with proper control measures. Azo dyes are useful, but we must use them carefully to protect our environment and health.